Let's solve this Olympiad equation together. It says 4 raised to the power a minus 36 raised to the power b is equal to 28. Now the first thing to do here is 4 can be expressed as 2 squared. Okay, all raised to the power of a minus 36 is 6 squared, all raised to the power of b to be equal to 28. Okay, now from here we can use the law of indices that say that a raised to the power m all raised to the power of n is equal to a raised to the power n all raised to the power of m is equal to a raised to the power m times n. Okay, but then we'll apply these parts here. So we rearrange this to become 2 raised to the power a all raised to the power of 2 minus 6 raised to the power b all raised to the power of 2 is equal to 28. This is something squared over something squared. Now let's rearrange this and call 2 raised to the power a to be equal to x and 6 raised to the power b to be equal to y. Okay, now doing that we have x squared minus y squared to be equal to 28. Okay, so x squared minus y squared follows the difference of two squares, and this becomes x minus y into x plus y is equal to 28. Okay, two things are multiplying to give us 28. Now let's find some multiples of 28. So 28 can be expressed as 1 times 28, 2 times 14, 4 times 7. Okay, so these are the multiples of 28. Now moving on, we need multiples such that when we substitute them for x plus y and x minus y, we will get whole numbers that we can use to solve further. Okay, just to make our work easier, but all these ones can be applied, but just to make our work easier and to give us a real number, we need multiples that when we equate them to this and this and we solve, we can get the number for x that is whole, and since x is 2 raised to the power a, we need a number that can be expressed in the basis of 2, and then 6 raised to the power b, we need a number that can be expressed as in the exponent of 6 for y. Let me use that and let's see if it makes sense. Now for the first one, we have that x plus y should be equal to and x minus y to be equal to. Now just because of what we've been talking about, x should be greater than y, because this should be greater than this rather, because this is x plus y. Okay, it should be bigger than x minus y if x and y are equal. Right, now so understanding that, now moving further, let's now say that this is 1 and this is 28. Okay, if this is 1 and this is 28, when you add, you have 29. 29 cannot be 29 is an odd number, so we cannot use that to solve. Let's try this. Okay, so this is 14 and this is 2. If we say here is equal to 14 and here is equal to 2, okay, solving with this, now if we add these two equations, we have 2x to be equal to 16 and hence x is equal to 8. Now you're seeing that we already have something that can be expressed as, so x now can be expressed to be equal to 2 raised to the power of 3. Okay, now let's find y from here. Y now become equal to, so because x plus y is equal to 14 and our x is equal to 8, it means that y is equal to 6, which can also be expressed as 6 raised to the power 1. Alright, now we write here, recall that, okay, from the first thing we said that 2 raised to the power a is equal to x, and our x is already equal to 2 raised to the power 3, so we write 2 raised to the power a is equal to 2 raised to the power of 3, hence our a is equal to 3. Furthermore, now we have 6 raised to the power y to be equal to 6 raised to the power 1. Okay, so 6 raised to the power b rather is equal to 6 raised to the power 1, which is y. Now b is equal to 1. Alright, we can now say that a is equal to 3, b is equal to 1. Alright, now let's substitute this into the expression we had. So we had 4 raised to the power a minus 36 raised to the power b. This is equal to 4 raised to the power 3 minus 36 raised to the power 1. This is equal to 64 minus 36, and this is equal to 28. Hence, you can now say that our answers are the correct answers to this equation. Thanks for watching.